Okay, so hopefully you're in the right place. This is Math 270, Calc 1. My name is Mark Ashbrook. You can call me Mark, I'm fine with that, but anything respectful is fine. If you're not comfortable with that, Mr. Ashbrook. I'm not a professor, but if you want to call me Dr. Ashbrook, that's great, makes me feel good. But you can call me Mark if you want. So let's talk about some just basics here. So this is going to be the way to get a hold of me, my email. Check this several times, basically in front of my computer all day, and have the bad habit of continually looking at this. So this is the way to get a hold of me. I try to get back to you as soon as I can. At the latest, it should take half a day. This is the longest it should take. Okay. All right. So Blackboard, ASU Blackboard. I'll show you that in a second. That's going to be our home base for the course. You should all be enrolled in the course for Blackboard. So the first thing is the syllabus. You're going to want to download that or print that, whatever you prefer. We'll go over the syllabus in detail Monday. Also on Blackboard is where all your written assignments, other course docs, the movie files of the class periods, those will be posted on Blackboard. Okay, exam results and grades. Let me just say about grades, I only use Blackboard to record your individual grades. Then it will take those numbers and try to give you an overall grade. Ignore that. If it says overall or total or compilation, just ignore that. I'm only using it to record your individual grades. So I try to make those columns hidden to you so you can't see that, but inevitably there's something that shows up that's trying to give you an overall grade in the course. On Blackboard, you can ignore it. I only use Blackboard to store individual grades. Okay, so there's an online text and homework. That's what you were required to buy. And that was a package deal. And really what we'll need that for is the online homework. Okay, so just the online homework was something like $8 less than the whole package. Okay, so it's not that big of a difference. And then you got my email about the, I don't have it with me, but that workbook, just the recitation workbook. When you open that package up, it still should be in cellophane. I'm trying to find out if you could sell that back, or maybe at the end of the semester, get some kind of refund on that. So don't open the cellophane. We're not going to use that. We're not going to use the recitation workbook. So I'm trying to figure out if you can somehow get a little money back for that. But we will use the online homework system. Not extensively. I mean, that's not going to be our regular homework, but we will use that online My Math Lab. Okay, and so then to log into that, here's the course ID. This is also on Blackboard. Ashbrook 47762. That's the course you need to enroll in for our class. Okay, so like I said, we won't be using this extensively, but this system, once you buy this, it's good for 271 and 272, and it's likely that in those classes you'll be using it a lot more. Okay, so I'm not wasting your money. Okay, so then in the last couple of days we've had some emails about this, the graphing software graphing calculator, and so we had a round 2 of registration. Were people successful with round 2 on registration? Okay, so it looks like that one's working. If you haven't done that, I'll show that to you again on Blackboard. You're going to need that. We'll be using this extensively. The course is kind of, this is somewhat of a centerpiece of a lot of the assignments and what I'll be using in class is this graphing calculator. And I think you'll really appreciate having this as free software. Very, very powerful for learning this stuff. And it can do a lot. And don't get this confused with a handheld graphing calculator. It's an unfortunate name that they name this software because it's not a handheld graphing calculator. Okay, it's software that you use on your computer, and it's 100 times better than a graphing calculator. Okay, so yeah, info about that. We'll go to Blackboard in a second here. All right, so let's go to Blackboard. So let me show you if you haven't been to Blackboard yet. Here's our home base. Okay, this is what it should look like. Your assignment for month, all assignments are going to be posted here on the left at the assignments. Right. Let's try it. All right, so when you click on assignments, here's the first one for Monday. So it's a little bit more than an assignment. It's a checklist and then the actual assignment. So on your checklist, you're downloading and printing the syllabus, and that's available in this course link over here. And then you're going to enroll in our My Math Lab course. Instructions are back on the announcements page. I'll show you that. You're going to download Graphing Calculator if you haven't done that already. Also instructions on the announcement page. And then 1, 2, and 3 are your actual math work. Okay, your actual math work for Monday. So going back to home base here. All right, so, oh, and then there's one more thing we'll talk about. So here's the information. If you haven't enrolled in My Math Lab, there's the information for that, where to go, and again, our course ID. And then acquiring the Graphing Calculator software, all the information is there. And the registration info is down at the bottom. Okay, one more thing to talk about. On Monday, so this isn't part of the assignment for Monday, but on Monday after class sometime, you're going to take a pre-test. That pre-test is in PSA 21. PSA is about 1/5 of a mile that way, north, down the Palm Walk, and 21 is in the basement. It's the testing center. So the testing center is open, will be open after class, starting at 10:30. You have to be inside before 6:30. The last exam's collected at 8:15. For this pre-test, note you shouldn't have a calculator. Don't need it. Bring a valid Sun card for all these for the testing center. And then the pre-test is a required element of the course, but you can also earn some extra credit. Depending on your performance on it, I'll give you a little bit extra credit on test 1. Okay? So it's required. Everyone has to take it. And this is going to give you an idea of how kind of ready you are for this course. Like I said, I'll give you some extra credit on one. So you've got the whole checklist for Monday is in assignments, and then on Monday after class you're going to head over to the testing center. Most students this takes, I would say, between 20 minutes and an hour. I'd say average is probably about 30 or 40 minutes for the pre-test. Maybe longer, maybe 45 minutes on average. Questions about Blackboard or anything that you're doing for Monday? Okay, so again, just go to assignments, and there it all is. Everything you need to know for Monday, August 27th. Okie dokie. So let's talk about this class. So this class is going to be, it's going to be a lot different than probably the math classes you've had in the past, and it's going to be a lot different than all the other Math 270 classes on this campus. I'm going to teach it in a different way. So to kind of lay out some expectations, give you some context, I want to talk about math education in the U.S. versus other countries, and just give an overview of what calculus is and how we develop it. Okay, so let's talk about some international comparisons. Okay, so this is comparing some different countries. It's basically the percent of 24-year-olds that have a natural science and engineering degree, and this right here, the blue, is showing in 1975. And it's showing that the United States was in second. So fast forward to year 2000. Here's where the United States is in natural science and engineering degrees, 5%. Okay? So, what is this saying to you? Okay, well, so can you, why? What's happening?
Degrees in those areas.
What's that?
We're not getting degrees in those areas.
Okay, so compared to other countries, the degrees are a lot less. But then what's the implications of that?
They get the jobs.
They get the jobs.
The education behind it might not be as advanced.
Okay, something happening in our education system? Other ideas?
They're more advanced, as in math courses and stuff like that.
Something's different in their math courses, okay?
I mean, just are the teaching standards the same? Because that can't be true.
What can't be true?
The teaching standards. There's no way.
Okay, so teaching standards would be different. Other ideas? What is this revealing?
People aren't coming to the U.S. anymore to immigrate?
Well, okay, so the mathematics education is certainly a big part of this. Another part of this is culture. Okay, so if you were to go to a party in Finland versus a party in the United States, what do you think that the chances are, that you'd run into someone, with an engineering or math degree? So 3 times as great in, say, Finland or Taiwan than the United States. Okay? And what do you think the perception or the attitude would be towards people there versus the United States?
It's more glorified, probably more respect.
Okay.
Here you have more respect if you were at a party and you met an engineer versus there because the majority of the population,
No,
or
I'm
more of
saying
the population.
the other way around.
The other way around. So
Okay.
Yeah, that here, if you're a math or science major, you're a nerd.
yeah, you're a brainiac, right?
That's true.
People that take math in the United States, if you're good at math, you like to take math. You're not normal, right? You're a brainiac. What about in Taiwan and Finland? It's normal. It's normal. Taking math classes, being good at math is normal. Okay, but so here it's kind of not normal, right? Okay, and so that whole attitude then reflects back into the culture of the classroom and the education that you receive. Okay, so that's a snowball that continues to make our situation worse. Okay, so companies that hire you are competing with students from these other countries. Okay, let's talk more about this. So there was a study about 10 years ago, and they videotaped 100 randomly selected 8th grade classrooms in Germany, Japan, and the US. And then they took those transcripts and they made them into written transcripts, and they stripped them of all kind of cues or clues that they were from, which country they were from. So if you read any of them, you wouldn't know which country you were reading. Okay? And then they rated those transcripts on the quality of the instruction. So by quality, we're talking about, was there a coherence of ideas versus was it just sets of problems to be learned? Okay? Or was there an overall, did it tie the ideas together? And then the significance of the ideas. Okay? So then based on those transcripts, Germany showed about a third of each. Okay? Japan, less low, more medium, and more high quality instruction. Okay, so what do you suppose happened, and what do you suppose percentages were for the U.S.?
Less high, less medium, and more low.
How much high? How much high quality instruction in the U.S. according to this study?
25.
Wow.
Okay. What do you think characterizes this low quality instruction, which is by the overwhelming majority of what's happening in U.S. classrooms? What does that look like? What would you think? So specifically, what is low quality instruction? Yeah.
Is the relationship between the teacher and the student and not understanding the material before?
Okay. All right. What else? What kind of things characterize low quality instruction?
Just the stuff I've seen here at ASU, coherence, like being able to talk to your professor, the students understanding the material, and like moving on. Usually, most students just don't care.
Okay, so I hear you both saying that the math students in the U.S. aren't coming out with understanding.
Yeah.
Why not? What's happening in the classrooms? What is characterizing math classrooms?
They're just given a set of problems and saying, do this.
Okay.
There's no teaching them how it works and how to get to that answer.
Okay.
It's just do it.
Yeah.
Same thing basically. How to do the problems, but not why the system or the method of doing it works.
Okay, how to do it. Was there a hand up here? Yeah.
The expectations are lower.
Expectations are lower. Okay. Yeah.
And for me, in my opinion, I like to learn why we do it instead of how we do it because I don't remember nothing.
Okay, so lots of you guys are emphasizing on this word how, and that's a big part of it. So can you identify to being shown an example with a series of steps and then having to replicate that? You do the steps now. Okay, it's just a procedure, or it's just rules to follow. Rules to follow and procedures to do. Okay, that's what turns out to be low quality instruction. And then lots of you mentioned, then there's no why. There's no understanding what's going on behind it. Okay? Okay, something's not working right here. Sorry. Nothing's cooperating here. Get out of this. All right, we'll keep going, but I can't get out of this. All right, so we're going to have that circle on the screen. All right, so calculus. Is it just a bunch of complicated procedures? So have you heard of Wolfram Alpha? Know what this is? He said yes. He likes this. What is this? It's called an information engine, and it's specifically a lot in the technical fields. Okay, so you can go to this website and you can ask it anything, including math problems. So like here, you could type in what is the integral of sine x cosine x dx from 0 to pi over 2. So this is a typical calculus Calc 1 problem that you see in this course. All right, hit enter, and look what it gives you. It gives you a representation of that. It gives you the answer. It gives you a graph that shows it. It gives you one Riemann sum, and then if you want, you can click and it'll give you more. Okay, so in the blink of an eye, it gives you all this information. Okay, the graphing calculator software. Here's a derivative. The derivative of x to the 3 to the x. Anybody taken calculus before? Some of you. Is this an easy derivative or a little more complicated? This is kind of harder, right? X to 3 to the x. Hit return. It just tells you what it is. Okay? So, we have software, we have the internet that's doing these problems for us that most calculus courses spend long hours, students learning how to crank out these algebraic formulas. Okay? But we have software that can do it in an instant. So what's the purpose of taking calculus if we can just, technology has gotten to the point where we can just hit a button and it's telling us the answers that normally would take 5 minutes to solve. Okay? Okay. So in the past, people learned these procedures to get jobs that require they do lots of computing. So before we had computers, there were people that sat at the desk and had to crank these out. Okay? They needed to be super fast at performing these procedures flawlessly. Didn't have computers to do it. Okay? They were given functions and equation. Their job was to do with them what they were told. It was more like an assembly line approach. Okay? So, oh, we need this derivative or this integral for this situation. So hand it to Bob. Right? Bob does integrals, and then Susie does derivatives. So we've got a derivative. You give this to Susie, so she'll crank it out. Okay? But we're in a whole different world now. You saw computers can do these procedures or calculus far more quickly and accurately. Right? It's much more efficient to have a computer do these procedures. Okay? But what can computers not do? They can't decide what function to analyze or what equation to solve. So that's where we come in. So we must decide these things in order to tell a computer to do them. So rather than a robot, rather than just cranking out a lot of symbols, so users of calculus, engineers, scientists, economists, they're more like managers today. Okay? And what about managers? What about the manager of a restaurant versus the waiter? What's the comparison? Manager have to know a little bit more? Yeah, manager has to know about the waiter's job and the cook's job and the maitre d' and the running of the restaurant. Okay? So they have to understand how it all works together to make it run efficiently. Okay, so users of calculus, you got to understand what you're doing, and you got to be able to explain why you're doing it. And that's our goal in this course. Okay, so what's your past experience in pre-calculus and calc? When you worked with symbols and preferred computation, to what extent did you understand what it all represented? Let's be honest. So maybe some halfway, others none at all. Maybe you had a teacher that was more along the lines of really asking why a lot, or what things meant. Okay, so this class is about developing an expert knowledge of calculus so that you can figure things out, not just remember what you should do. Not just follow the rules. Okay? So if something I present as new, it seems familiar, then pretend it isn't. Pretend like you're starting over, okay? Try learning it with understanding and meaning. Okay, what's the moral? Good math instruction in U.S. schools is not good by international standards, okay? And don't expect this class to reflect your experience in a prior math class you had. So I'm trying to lay out the expectation here. It's gonna feel different. It's gonna feel different. What this class is not about. Rote memorization, replicating examples and procedures, doing without thinking just to get an answer, and guessing what I want you to say. Okay? What it is about. Using your uniquely human capacity to think in order to understand ideas, develop insight into the world of quantities and relationships, and then see ideas as coming in groups. Okay, it's not going to be a set of isolated ideas, but ideas that are tied together. And then, moreover, calculus has kind of a couple of really big ideas, and everything we do is kind of a long endeavor towards really understanding the main point of calculus. And we'll talk about that in a second. Okay? So, when you're posed a question or a problem, expect to have to rely on your understanding to solve rather than an example or a procedure to replicate. Expect to have to bring together multiple ideas sometimes and to transfer your knowledge to a new situation. Okay? Expect to have to write out explanations. So lots of times I'm going to say, explain your thinking. And so that means complete sentences to really flesh out how you got from point A to point B. What was your thinking? Explain. And expect to get help or a hint when you're having difficulty, but don't expect someone to come and do it for you and tell you the answer. Okay? So what I'll do, and students get frustrated with this, but after a while they get used to it. If you ask me a question, oftentimes I'm just going to ask you a question back. Okay? All right? Because I want to listen to your thinking. I want to hear what you're thinking about it, and then get you to help you start thinking more correctly about it. Okay? And so that will often mean that I'm going to ask you a series of questions. All right? Questions that I think you can answer, and will get you to the question that you have asked. Okay, so in summary, thinking is hard work. It takes patience and perseverance. So some of you won't be used to this. It will feel very uncomfortable. But the benefits are great, and many. And eventually, when you do this enough, when you learn to take the time to really think, then it becomes like you like it. You like that struggle because you like it when at the end when you figure it out. Okay. Okay, so let's talk about just a brief overview of calculus. There's two fundamental problems that calculus addresses. The first is, you know how much of a quantity you have, okay? And you want to know how fast that quantity is changing. Okay? So you know how much of something you have, and you want to know how fast it's changing. The other is, you know how fast a quantity is changing, and then you want to know how much of it there is. This summarizes pretty much all of calculus, so you can keep this in the back of your mind. This will help you kind of see why we're doing what we're doing at any given point. Okay, so the first one, you know how much of something there is, you want to know how fast it's changing, that's differential calculus. And you know how fast something's changing, and you want to know how much of it there is, it's integral calculus. So differential calculus, well really, so if you know how much of something there is, you want to know how fast it's changing, well, the changes accumulate, and then you're talking about integral calculus. Similarly, integral calculus, you know how fast it's changing, you want to know how much there is, that leads us back to differential calculus. So they're just two sides of the same coin. Okay? And kind of that one idea is rate of change. Okay? Rate of change is the big idea here of both differential and integral calculus. So we'll be constantly talking about rate of change. Okay, there was a grad student a while back who did a study of 100 calculus students and their understanding of rate of change. And so she did some kind of pretest of their understanding of rate of change before the course, and then they took the calculus course, and then she did a post-test to assess their understanding of rate of change at the end of the course. And her findings for these 100 students was that, believe it or not, their understanding of rate of change was lower at the end of the course. So why do you think that is? What happened in this course? Why do you think that their understanding of rate of change is actually less by the time the course ended up? Any idea? Okay, so what was happening in that calculus class? Memorization. What else? Okay. Teacher gave them the answers. So, and mostly what were they focusing on, would you say? What's that? Yeah, so learning these rules, all these derivative rules and integration rules, and learning how to do these rules and procedures for finding derivatives and finding integrals. And all of that, the understanding that they had of rate of change was lost even more. Okay? Okay, so now I need to get unstuck here. Oh, something happened. Okay. But, so this morning there was a 4-minute rain shower. Did you notice that? It takes me 7 minutes to ride to work. Guess when the 4-minute rain shower was?
The time you're ready.
Yes, right in the middle. All right, force the click. So while I'm fixing my computer here, any questions about anything? About my math lab, about downloading graphing calculator? Any of that? Anything? Yeah, if you have a laptop, that would be great. So download that graphing calculator on your laptop, bring it to class, okay? And maybe we may have some access to, for those of you who don't have a laptop, I think we've got laptops there we can use in class. But if you have a laptop and it's going to have the, put graphing calculator on that, and bring it to class. Any other questions? You won't need it. Yeah, everything you can do with a handheld, you can do with the software. So it's all you're going to need. Yep. It does, like I showed you, it does numerical computations, algebraic computations, and then all the graphing. Yeah. So we'll have to figure out what exactly you have. I'm not sure yet. I'll have to decide as I'm thinking about and writing the exam what it is you'll be given. Okay, let's give this a shot here. See if I can get this to work. Okay, so let's just do a little intro here. We got about 15 minutes left. Let's talk about quantities, okay? All right, so here's the situation. Instructions on a drink mix container say that 16 tablespoons of powder should be mixed with 60 ounces of water. Okay, so how can we model the quantities with an illustration? So I'm not saying I don't want to illustrate a pitcher of water. Okay, I don't want to, I'm not a good artist. So, and I don't want to draw scoops of powder. Okay, I want to model the quantities with an illustration. So, can you think of a way that we could just the quantities themselves model those with an illustration?
I mean, you type in like a graph.
Okay, some kind of graph. Okay, anyone more specific? This is probably a type of graph that you haven't seen before, and so it's bars. We're gonna call it bars. All right, the length of the bar represents the value of the quantity. Very, very easy. So here we go. So I'll give you the bars there. So I want you to illustrate the situation using the bars. Nice, easy question to start off, right? So how could you illustrate the situation I gave you with these bars? Someone want to offer up what you did or what you're thinking? How can we use these bars to illustrate that 16 tablespoons of powder should be mixed with 60 ounces of water? There's nothing tricky about this. Yeah.
Have the long one represent the water and have the short one represent the powder?
Yeah, like I said. So you want the long bar to be the volume of water. Okay? And what is the volume of water? 60 ounces. Perfect. Okay. And what about somebody else? What about the other bar?
The powder.
Amount of powder. How much? 16 tablespoons. Okay, easy start. Okay. Now, same diagram. Here's the question. How many ounces of water should be mixed with 1 tablespoon of the drink mix to achieve the right taste? Okay, so here's the one rule. No cross multiplying. That's off limits. No cross multiplying. Use the illustration. So use this illustration. The bars come up with a way to illustrate this in order to help you solve this question. How many ounces of water should be mixed with 1 tablespoon of mix to achieve the right taste? And so you can work together whenever. So unless I specify otherwise, if I have you think about or work on something, you can always trade ideas and work with people next to you. Okay. So I'm not asking for a calculation. Okay, I'm asking for you to represent it, illustrate it, represent that.
Break it up into 60
Okay.
pieces. Yeah. Break it up into 60 pieces.
He doesn't want us doing an equation. So yeah, we split it up 60 to 40 each. What? For the value, obviously, 60 ounces, so 1 tablespoon.
Okay, anybody want to offer up the way you thought about it, the way you used the, right here.
Just break them both into 60 pieces.
She said break them both into 60 pieces.
16.
16.
Oh, 1 tablespoon. Okay.
So
16.
she wants to break them both into 16 pieces. Okay, so down here if I'm down here and I kind of mark off, make a mark here, then we want that to be how much? 1 tablespoon. Okay, and that length is what compared to the whole length?
16.
That's 1/16 of our 16 tablespoons. And so if we want the right taste, how much water? So how do we use the diagram then? What about the top bar?
Break it up into 16 pieces again.
So she wants to break that up into 16, or maybe just, so there's going to be some amount here of water that corresponds to that amount of powder that gives us the right taste. So somebody take it from there. So again, we're after this. What is this amount right there? Somebody new. So again, what did this represent right here?
That's 1 of 60.
What's that?
1 of 60.
1 of 60. So 1 ounce? 1 of 60? Okay, but we want the process, not the final answer. So what's the process? Yes, sir?
60 divided by 16.
Where does that come from?
Divide 60
Okay, so you're looking at this piece right here, and what are you seeing? That's what? What's that?
16.
That's right. So if this is 1/16 of the amount of tablespoons, then this has to be also 1/16 of 60. And then that is 60 over 16. Okay, anybody have a question on that? Or have an alternate way of thinking about it? So the thing about these is there's different ways to think about it. So if you have a different way, do you want to offer that up? Okay, so let's see if this works this time. There we go. All right. Same situation. 16 tablespoons mixed with 16 ounces of water. Now I want you to use the bars to solve and illustrate how much powder would be required for 200 ounces of water. This is harder, a little bit harder, okay? Relative to the course, this isn't hard, but this is a little harder. Okay, so again, no cross multiplying. Use the bars to illustrate what's going on here, okay? Work together. So this is a little more involved. Go for it. And this is it. This is what you're given. You can't make a longer bar. You can't extend the bars, okay? You got to use these bars. So draw it. Draw it up. So draw these bars on your paper, like I did on the last screen. Use the bars to show the reasoning behind moving towards that, solving that.
Well, I know like this one we have,
What's that top bar going to represent? What are you saying that top bar is going to represent?
it's gonna represent 200.
200, okay. I think that's a good start. Yeah, just use the two bars if you can. Oh, were you doing it on the screen? Sorry. So this is about the visual more than it is about. Unfortunately, calculus is very visual. Get used to it. Okay, it's a good start. So lots of you chose on that top bar to represent what I saw. This is a good start. What'd you do? 200, okay? So then what would the bottom bar represent if the top bar represents 200? What's that? 16,200s? What did you say over here? What does the bottom bar represent then? Yeah, so this is our unknown quantity, right? So how are we going to figure out what the length of that bar is? Any ideas from here? Yeah?
Wouldn't it just be 1/16 of 60?
1/16 of 60. Where's that coming from? So,
What we just got from the last exercise.
okay, 1/16 of 60, that's how much powder or how much water would go with 1 tablespoon, right? So we have 200 ounces of water. We don't know how many tablespoons we have. Other ideas? Yeah. So visually, when you say divide 200 by 60, what do you mean for the diagram? Right here? Okay, so we broke off 60 of the 200. Then, sorry, what did you say after that?
Like 200 divided by 60 to get like how much bigger it became. So like 3.33 or something. And then you multiply that by 16 to get the bottom one.
So 200 over 60, what does that number represent? No, what does it represent?
The amount that's in the
It's the ratio.
Okay, well, ratio is that's a very general word. Well, exactly, what does the number 200 over 60 represent in this situation?
How much bigger the new bar is?
What's that?
How much bigger the new bar for water is?
Okay, so how much bigger? So it's kind of like a magnifying factor. So it's if we had 60 ounces of water, this would be how much we just magnified it by. Okay? How does that help? So we've magnified our water by 200 over 60.
We can use that same relationship for the bottom bar.
Okay.
Since it's staying on.
So 16.
So x equals 16.
So you want to magnify somewhere here is 16 tablespoons, right? And those correspond.
Right.
And so if we magnified our 60 by 200 over 60, then to get the corresponding number of tablespoons, we would magnify 16 by that same magnification factor. Does it work? So when I did this last night, I did it 2 different ways. This was not one of them. So there's multiple ways to do this. Okay, so I had 2 other ways to do it, but this works great. Okay, 200 over 60 represents how much we would magnify 60 by to get 200 ounces. So we got to magnify our 16 tablespoons, which corresponds to 60, by that same magnification factor. Any questions, comments? Nice. Okay. So let's see here. Let me just go back to this Blackboard. We just talk about, just really quickly here, before I let you go. We talked about the bullet points. So what you'll do for homework for Monday, the actual math part of it, there's a link here, and it's like a 3 or 4 page kind of text. You're going to read that, but you're only going to go through where it comes to exercise 6 on page 3. That's as far as you need to go. And then you're going to answer exercises 1.1 through 6 on separate notebook paper. This grade is going to be based less on correctness and more on your presentation, organization, neatness, and complete sentences, and if needed, illustrations. Okay? So I'm looking for what it looks like, and you're just showing that you were thoughtful about it. Okay? And then 3, based on the reading, be ready for a short quiz on a particular statement in the reading. And that'll be the beginning of class on Monday. Feel free to email me if you have any questions. Okay? We will see you Monday. Hello.
I'm Alexandria. I'm the one that's been emailing you that I couldn't download.
Oh, you're still having difficulty?
Yeah.
Okay.
Show you.
Yeah. Let me make sure I got this turned off here.
Excuse me. Should I?
No, I am done for